Okay, so let's look at this particular example. Everyone knows that cars and trucks lose value the more they are driven. Can we predict the price of a used Ford F-150 Super Crew 4x4 if we know how many miles it has on the odometer? A random sample of 16 used Ford F-150 Super Crew 4x4s was selected from among those listed for sale on autotrader.com. The number of miles driven and price in dollars were recorded for each of the trucks. Here are the data. Here is some computer output from a least squares regression analysis of these data. Construct and interpret a 90% confidence interval for the slope of the population regression line. All right, so this is it's a linear regression problem with two variables. The variables are miles driven, x, and then the y is the y hats. I'm sorry, these are the y's, actual y's. And then this is x and this is y. So notice it looks like it's a list, 4 lists. It's not. It's only 2 lists. 2 lists. If you really want to type this in, you can. But it isn't necessary to type this in here. So before you go, crazy trying to type in digits after digits and hoping that you don't do a mistake, stick with me here so you could see that you don't really need to do typing them into a list. All right, we're going to start by looking at the question, and it's the interpreting a 90% confidence interval for the slope. Okay, 90% confidence interval. So we're going to start by stating we are doing a 90% confidence interval for the slope, which is beta, this b, with this line a little longer. And that is and I like to put the word true in there, the true slope of population regression line relating y equals price to x equals miles driven for used Ford F-150 Super Crew 4x4s listed for sale on autotrader.com. As you can see here, we should have added for the price the units, and I forgot in my notes. So that. And then for the units for x, since it's miles driven, it's already in the context of the variable. You don't need to write miles again. We're planning to do a t interval for slope. And now we're going to check the conditions, which is extensive. So linear, we're looking at the scatter plot, shows a clear linear pattern. Look at the scatter plot. This is the scatter plot. Do not confuse these two. This is not a scatter plot. This is a residual plot. See the word residual? This is your residual plot. There's a difference. And this is a scatter plot. And so looking at the scatter plot, there is a clear linear pattern for the scatter plot. But the residual plot shows no leftover obvious pattern, so that's a good thing. Past the linear requirement. Independent, our population must be more than or equal to 10 times 16, which is 160. We need to assume there are at least 160 F-150 Super Crews on autotrader.com, basically. Okay, that is more accurate. Or on sale, that would be even better, on autotrader.com. Okay, normal. There is no strong skewness or outliers in the histogram of residuals. So we're looking at the residual histogram. This appears to be roughly symmetric. There is no obvious outliers or strong skewness on the in the histogram of residuals. And then the equal SD. The scatter, this is how your book words it, the scatter of points around the residual equals 0 line appears to be about the same at all x values. So the scatter about the residual equals 0 line appears to be about the same at all x values. Random, yes, the sample was selected randomly. And now our degrees of freedom is 16 minus 2, so 14. And we use the graphing calculator to find this if we choose to type these into the graphing calculator. And let me show you where to do that. I'm not going to do it that way, but I do want to show it to you in case you don't remember how to use the formula. The formula is given to you on the AP exam, but just in case. So you would type the lists into, stat edit, but then you would go to stat tests, and then you would go down here, and it's lin reg t int g, and you would feed the lists, L1 and L2, or whatever list they are. Frequency, you would just leave one. Regression equation, you can leave it blank. If you wanted to store the regression equation into your y variable, you can go into vars, y, vars, etc., and type that there. And then you have your confidence level, which is, in our case, 90. So this would be 0.9. And then when you hit calculate, it should give you this interval. Okay. Now, as you can see, it might be less work just to do it this way, though, because even though this looks more like writing here, to be able to do this in the calculator, you would have to list a ton of numbers into your lists, two lists, and make sure you don't make a mistake, which can be tricky, okay? So how would you do it this way? Well, our formula is that B plus or minus T star times SEB. That's the formula. B is the sample slope, T star is your, test statistic for the T distribution, and then standard error of B. And I can tell you that they're all here on this line, right here, all of what you need. And so here is B, little b, this is B, and this, and I did point out to it actually, it's right here. I did this, and then here, this is your slope B, and this number here is the standard error. So all you have to do is calculate T star. And to calculate T star, it's a 90% confidence interval, so the tail under the area is 0.05, the degrees of freedom is 14, and we do INVT, and we get negative 1.761, so the T star is the positive version. If you put this on on your paper, if you write this on your paper, you must include the variables of the functions on there, or else they do not give you full credit for that. I would suggest don't even write this on your paper, find it on your calculator, and just write T star. Okay, so you take your B plus or minus that 1.761 times that. And those two multiplied is this. And then this plus or minus that is these two numbers. Make sure it's the smaller number and the larger number in that order. If you flip-flop them, you will not get full credit. This is an interval. It always must be the smaller number and then the larger number in that order. But if you do not trust yourself to do the math here properly or write this interval properly, you are going straight to the list and typing these in as fast as you can in list 1, or one list, and then the second one is this one, all of this into list 2, and make sure that you're matching these and you're not rearranging numbers, and you're, hope that you typed it in well. All right, and then we finally conclude. We are 90% confident the interval from negative, there's a 0 there. I have to re-upload this file. It's too many mistakes. Negative 0.02174 to negative 0.1084 captures the true slope of the population of the regression line relating y equals price in dollars. 2x equals miles driven for used F-150 Super Crew 4x4s listed for sale on autotrader.com. All right, here's another example for you to do. Try this yourself and note that I have the calculator version here, although this list is small, so it might not be as bad to just try it out with typing it into the calculator and just getting it this way. Or you could do it by calculating by hand on this one. Notice here's my slope and here's my standard error, and our t-star is 2.26 here for a 95% confidence interval with degrees of freedom 9. And another example for extra practice if you want.